Welcome back. Welcome back to this series of talks on getting a quantum leap in machine learning performance. Hopefully, if you've seen the overview, you'll have heard about how excited I am about combining graphs network data with machine learning approaches. And I've told you a bit about who I was, right? And perhaps why I've got some credentials to come and talk to you about this stuff. Whatever. Okay. So this is the first talk. It's part one, an introduction to graph machine learning. And I am Harry Powell, Head of Industry Solutions at Tigergraph. Okay, so have you noticed how all the data you've pretty much ever seen is in sort of rectangular format? Okay, so you've got NoSQL and that kind of stuff, but even so, it's still kind of rectangular, right? You've got columns and rows. Data seems to be put in columns and rows, and this is a kind of a, you know, a kind of a bit of an idea as to what it might look like. You know, people, houses, telephone numbers, transport, right? It's all kind of neatly arranged, right? And we have all these relational database schemas that kind of put everything in rectangles or squares. Okay, but have you also noticed that real life is not really like that, right? We have relationships between things that are not in squares, right? And you know, in this picture, maybe a man and woman share a car and share a house. That's kind of interesting thing to know, right? Maybe they're married or living together. But interestingly, that the man has used a computer that the woman doesn't seem to use. That's sort of interesting. Further down, you've got a man and a woman who sometimes seem to be in the same flat, but the man also has a house. Interestingly, the two women seem to share a telephone number, but don't share a house. That's kind of interesting too, right? There's all sorts of interesting things you can see in this to do with the connections between things that are not rectangular, right? That are much more arbitrary, much more heterogeneous in the way that things are structured. And yet the relationships between them are really, really important. And in fact, what we found in my work and our work at Tigergraph and other graph research as well is that if you're not using those relationships, those non-rectilinear relationships, you end up throwing half, you know, I say half the information away, a good chunk of your information away. You're just throwing it away. I've kind of replaced them with trash cans or rubbish bins in the UK, right? You're throwing all this information away. This is information you have, right? But by putting it in and keeping it in tabular format, in tables, you are unable to use it because the real world is not in that shape, right? And that's kind of the starting point for all the thinking around this thing called graph. I'm from this place called how does it work? I can't get my hands right. From Tigergraph, right? Sometimes Tigergraph, right? I'm from this thing called Tigergraph, graphs and networks. In this case, we're really passionate about it. And this is really why. There's so much information in the connections between the data points that you may well not be using if your analytics and machine learning is focused around tables, right? And what I'm trying to do in these talks is to get you to think about how you might be able to use this stuff, because the result of it is phenomenal, right? Particularly in certain kinds of use cases. Okay, so graph databases are the way that the world tends to deal with graph information. I mean, you can code it from scratch if you like, but graph databases are built from the ground up to do this stuff. It's kind of an unhelpful name because graphs and networks, we're not talking about charts and plots and diagrams here. And databases, well, yeah, these things, they're called graph databases, but they're really analytics and machine learning platforms, right, that work on graphy data. They hold data in graphs, but they're really about the analytics. They're not really about storage. Okay, and there's a number out there. Tigergraph is one of them. They each have their own particular advantages. So I work for Tigergraph. Bear with me for a minute or so. This is the point at which I'm going to tell you about why Tigergraph is great in certain circumstances. The real point about Tigergraph is that while other graph databases are available and they do great things at smaller scale, only Tigergraph has the power to do real graph machine learning of the graph databases available right now. That's our selling point, right? Other graph databases do other things really well. Ours is about power and the ability to graph machine learning. In particular, if you're going to do graph machine learning, you need scale. You need to use all your data, and you can't, when you partition it, you've got to keep all the connections, right? No other graph database, none of the main graph databases certainly, is able to do that apart from Tiger Graph. And if you don't, you get the wrong answer. It's not just about accuracy, it's actually about getting the incorrect answer. If you eliminate the key connections in your data because you have to partition it, you got problems, right? Also, in order to do graph machine learning, you need to be able to run algorithms within your graph, right? And again, only Tiger Graph seems to be, is built from the ground up as a native graph database with the speed, because we're written in C++, with the speed to be able to do graph machine learning, right? And this is the speed in graphs is very non-linear. So if you're a little bit slow over 1 or 2 steps through the graph, we'll come on to what that means, then you're going to be infeasibly slow with 10. And obviously, if you're running graph machine learning, you're running algorithms, you're wanting to iterate, you want to do lots of moving and exploring through a graph. If you're not fast, you simply can't do it. And other graph databases can't really do it at scale with the speed they need. Tiger Graph is also able to run real time. It's ACID compliant over distributed data. What does that mean? It means that you can actually connect Tiger Graph into your operational systems. If you want to run a personalization machine learning algorithm, you kind of want to be able to personalize in real time. We're the only people that can do that. And then finally, although we are not open source, you'll find that we're actually cheaper because we're able to operate at the speed and scale you need, and because we compact data in order to do that, we're much more parsimonious with the resources we use. So when you're running a graph database, you'll find that the cost of it is significantly the cost of the infrastructure. It's an in-memory database. They're all in-memory databases. What you need to worry about is how much you're paying your cloud provider, much more than how much you're paying for your license, right? And you'll find out that over the total cost of running Tiger Graph, because it's so much more efficient and performant, will be lower than any of our competition, right? So that's Tiger Graph, right? That's why you want to listen to me on Tiger on talking about graphs, right? Take that as you will. Other people will disagree, I'm sure. Everyone's got their own product to sell, but that's why I'm talking to you about Tiger Graph, and that's why I'm so excited about Tiger Graph in this case. Okay, so let's start off, right? I've made the claim that you want to use connections in your data. You absolutely do, right? There's so much information in there, right? And the result of that is that we've actually found that you can get huge boosts in machine learning through using those connections, right? This is empirical evidence, right? We're working with tier 1 banks in the United States, on Wall Street. I think most of the tier 1 banks are working with us now in the US. We're working, say, take for example, fraud models. So fraud is a typically graphy problem. You tend to find that fraudsters are connected to each other. If you can understand those connections, if your machine learning can understand those connections, then you can predict who is likely to be a suspicious account. We found that even on their highly tuned models, we were able to get a 20% increase in AUC-PR. That's precision recall, area under the curve. That's like a really key metric. And that's a massive step up, right? It's a massive step up. And we've done that, and I'll tell you how you do it in the next talk. But a massive step up in the performance of those models through using graph, right? It actually wasn't that difficult. The result for those banks, more than one of them is saving over $100 million in profit per annum, right? Making $100 million of profit, right? Saving $100 million of costs per annum through doing this, right? This is not a peripheral thing. This is, these are absolutely massive, right? And in fact, JP Morgan recognized the value of using graphs, and Tiger Graph in particular, by giving us their Hall of Innovation Award at the beginning of 2022, end of 2021. Right. So, and that's a really, really prestigious thing, right? Not many people get it. Certainly not many companies of our size get that thing, right? So here, the message of this slide, right, is we've seen this thing, right? We've seen the impact that taking graph features into, or taking graph graphiness, connectedness into your machine learning can do, right? It's not peripheral. It's big steps up in accuracy. It's massive amounts of value that some of these more sophisticated banks are getting. Okay, so here are some sort of use cases for machine learning. I call it tiger graph machine learning. Get any graph machine learning if you can do it on another graph. Doubt it, but if you can. So financial services fraud detection is a really, really big one, right? And that was the basis of the numbers I've just shown you, but we've seen it elsewhere. Credit scoring, it's not just what we know about an individual, but how they're connected into their communities, which may determine how likely they are to pay back a loan that you make to them, right? Asset pricing. All these assets are connected, right? When treasuries, when US treasuries moves, that moves the price of all sorts of things, but also when individual companies default or the price of their stock might go down, that's going to have a ripple effect that goes throughout the markets, right? A small ripple effect, and it may diffuse in lots of different ways, but asset pricing is a really interesting use case for graphs and graph neural networks in particular. In retail, right? I mean, personalization is huge, and we'll talk about personalization in a later talk. But personalization that works with new customers and new products, right? Where you don't know anything about the customer, where collaborative filtering, people like me also buy, those kind of things. We can get by that around those problems with graph that you simply can't if you're not using the connections between things. Demand forecasting. Effectively, the demand of one thing is going to be in some sense informed by the demand for others, right? The demand for, I don't know, bread and cheese, right? If you eat them together, then somehow those two demand things are linked. In retail, graphs are increasingly becoming the state of the art for how you understand demand. And customer journeys too. I mean, they're clearly graphy, right? One person is a journey is a sequence of events, but there are all sorts of issues around doing machine learning on those that you can overcome when you're working with graphs. And then finally, manufacturing, supply chain is something that is a core kind of use case for graphs in general, not just for tiger graph, but other graphs as well. Where I think the machine learning comes in is around inventory optimization, multi-echelon digital supply networks, right? Maximizing flexibility and minimizing stock. The game is not just about how you minimize stock, minimize inventory nowadays. You want to maximize flexibility and use all the possible optionality within your network to get around problems of supply that we're all seeing at the moment. Process optimization, I guess, is some sort of similar thing. Lots of manufacturing businesses have process automation software, process mining. Machine learning takes it a step further, and using the graph can take all that data that they currently store from logs effectively in manufacturing processes and can give it new life with predictive power. Okay, so there are some sort of use cases. I'm just going to kind of give you a little bit of a flavor of what's to come. So in the kind of quick win talk, which is the next talk, we're going to be talking about how you can augment existing machine learning applications using graph features, right? This is the quick win. This is the quickest way of making a whole load of money and a whole load of accuracy out of graphs. It's perhaps not the most intellectual, but that's the basis of the 20% boost that I showed you in AUCPR on a previous slide, right? We simply augmented their existing systems, right? We didn't rebuild anything. There was no re-architecting. It was really quick and really easy. And we'll talk about that in the next talk. And then after that, I'm kind of giving you this kind of picture. I probably won't explain it in great depth. But the two talks after that will be about graph neural networks. And this is about how you can build networks of, say, in this case, products, maybe in a retailer, in a grocery store, in a supermarket, and how, because they are related together, when in this example you see a change in demand for cornflakes, you'll also see a change in demand for bread through an intermediary connection, because they're both carbohydrates. So cornflakes and milk are also related because they're both breakfast foods. You can see it in this graph. The point here is this connectedness and an ability for information to flow through a network, and the use of that in machine learning to predict around that is incredibly powerful. It's super powerful. This is the thing that I'm most excited about. And I'm really looking forward to sharing that with you on the third and 4th talk in this series. So you're going to have to wait a little bit for that to come up, but it really is worth waiting for. And just before we go, because this is kind of an introductory talk, and we've really talked here about, in the generalities. Just want to let you know about TigerGraph Machine Learning Workbench. This is a really cool new tool that allows you to think about graph machine learning, because what it does is it allows you to connect your favorite frameworks, cloud providers, tools, pre-built models in the cloud world directly through to TigerGraph as a back-end graph database, so that those cloud tools behave as if they were already built natively on a graph database. Right. So that's super powerful, right? That brings the graph into the machine learning and allows you to access it in a completely different way. So again, really looking forward to telling you about that. I wanted to kind of let you know that this is where we're going, right? This is where we're going, a way of putting graphs natively into the tools that you have chosen to do your machine learning with. So here's a summary. If you don't use relationships in your data, you're throwing half your information away, right? And we're seeing massive improvements from people who are using those relationships, who are using those connections. And in the next talk, we'll talk about how to get a quick win, augmenting your existing machine learning with graph features. Before we go, if you're interested, right? If you're already interested enough, even before the second talk, you can get a free TigerGraph Cloud instance. I think it's 50 gigs. Given the compaction of data that we do in Graph, that's actually pretty decent amount. You should be able to do some good stuff in there. Get a TigerGraph Cloud instance for free. There's the website. If you want to talk more, even at this early stage, please get in touch with me. I'm Harry Powell. Send an email to sales@tigergraph.com and they'll put us in touch. I'm really looking forward to either talking to you or sort of seeing you, although obviously I won't see you, but you're going to be seeing me, hopefully, in the next talk. Yeah, have a great day. See you then.